First generation. When we talk about the first generations of the computer, we need to consider the processing power, size, efficiency, and overall capabilities of the computer. So, the first generation of computers relied on vacuum tubes, which were used for both circuitry and memory storage. These early machines were massive and primarily used for scientific and military application. When we see the key features of this computer, the first one is the size of this computer. When we talk about the size of the first generation of the computer, it was enormous, often filling entire rooms. When we talk about the speed of this computer, the processing speed was relatively slow due to the limitations of vacuum tubes. We also talk about the power consumption of this computer. These computers consumed large amounts of electrical power, leading to high operating costs. Okay, now let's see the most common examples for the first generation of computer. The first one is electronic numerical integrator and computer, which is one of the general-purpose computers. Okay, the second example of this first generations of computer is Universal Automatic Computer, in short, UNIVAC. This is the first commercially successful computer. When we see the impacts, the first generation of computers laid the foundation for modern computing by demonstrating the potential of electronic data processing. However, their size, inefficiency, and limited capabilities hindered their widespread use. Second generation. The second generation was the replacement of vacuum tubes with transistors, which were smaller, more reliable, and consumed less power. Transistors made computers more compact, efficient, and affordable. Okay, now let's see the main and also the key features of this computer generation. Size. The size of this computer is transistor-based, which means computers were much smaller than the first generation of computers. Okay, when we see the speed, this computer processing speeds improved, making computers more practical for commercial and research purposes. And also for the reliability, transistors were less prone to failure than vacuum tubes, improving the overall reliability of computers. Now let's see the examples of the second generation of computers. The most common examples of this second generation computers are IBM 7090, which is a highly successful transistorized computer used in scientific and business applications. And also, the other one is CDC 1604, which is one of the first computers to use transistors, used for scientific calculations. Those computers are the most common types of the second-generation computers, and when we see the impacts of the second generation, marked a significant leap in computing, as it brought computers to a wider audience, including businesses and research institutions. They are considered as the introduction of more reliable and faster computers, which helped to establish computing as an essential tool in various fields. Okay, now let's move to the third generation of computers. The third generation of computers introduced integrated circuits, where multiple transistors were integrated onto a single chip. This reduced the size of computers further, while increasing processing power and efficiency. Okay, let's see the main points from this generation. The size. According to the size, this generation of computers have integrated circuits, which allows for more compact and powerful machines. So the size is decreasing according to the previous generations. The speed? The speed of this generation computers became faster, able to process data more efficiently. The heat generation. These integrated circuits produced less heat than individual transistors, which led to improved system stability and performance. So, what are the main examples for this generation of computers? Okay, the first one is IBM System 360. This is a family of computers that demonstrated the versatility of integrated circuits in various industries, and the other one is PDP-8. This is one of the first commercially successful mini-computers, marking a shift towards more affordable computing. So, when we see the impact of this generation of computers, integrated circuits revolutionized computer design, making computers more accessible and affordable for a wide range of businesses and industries. This generation paved the way for the development of more advanced computing systems. Okay, now let's move to the fourth generation of computers. The fourth generation introduced the microprocessor, which combined all the components of a computer's central processing unit, CPU, onto a single chip. This innovation drastically reduced the size and cost of computers, leading to the rise of personal computers. So, the size of computers became smaller and more affordable, allowing individuals to own personal computers. Also, according to The Powers, microprocessors made computers significantly more powerful, capable of handling more complex tasks. And for the user interfaces, the development of graphical user interfaces, GUI, made computers more user-friendly and accessible to non-experts. Okay, now let's see the main examples of this computer generations. The first one is Intel 4004. This is the first commercially available microprocessor, enabling the creation of personal computers. And also the other one is Apple Macintosh. Also, this one is a popular personal computer that brought GUI to a wider audience. So the impact of the microprocessor revolutionized computing by making powerful, affordable computers available to individuals and businesses alike. It laid the foundation for the personal computer PC revolution and the rise of software development, fundamentally changing how people interacted with technology. Okay, the next is the fifth generation. The fifth generation of computers is characterized by advancements in artificial intelligence, AI, machine learning, and quantum computing. These technologies enable computers to learn, reason, and process data in ways similar to human cognition. Okay, this generation of computer have some key main features like artificial intelligence. AI systems are capable of performing complex tasks such as natural language processing, image recognition, and autonomous decision-making. Quantum computing. Quantum computers use the principles of quantum mechanics to perform calculations much faster than classical computers, solving problems that were previously infeasible. Automation. The development of smart systems and robots that can perform tasks autonomously in fields like healthcare, manufacturing, and logistics. Now let's see the main examples of this generation of computers. IBM Watson, an AI system that can analyze large datasets and answer questions posed in natural language. Also, the other is quantum computers. It is still in the experimental phase. These have the potential to revolutionize fields such as cryptography and drug discovery. Okay, when we see the impacts, the fifth generation is pushing the boundaries of what computers can do, with AI and quantum computing expected to revolutionize industries such as healthcare, finance, and logistics. These advancements have the potential to solve some of the world's most pressing challenges, such as climate change, medical diagnostics, and sustainable energy. So, each generation of computers has built upon the advancements of the previous generation, which led to the computers we use today. The evolution of computers has made them faster, smaller, and more powerful. From room-sized machines to today's intelligent systems, computers have transformed modern life. With emerging technologies like quantum computing and AI, they will continue to drive innovation and shape the future. Thanks for watching, and I will see you in the next video.